Okay, moving on from that last example, we're going to go after some different polynomial exponent equations right now. And you can see, for one thing, in those last examples, what did I have? I had an equal base in each one at the very start. Well, this time it's not so easy. We're going to have some equations with different bases. And it doesn't change a whole lot. It just means one more step at the beginning. We still want exponential equality if we can find it. So what I'm going to do in this one is recognize that 8 is just another kind of 2, right? It's 2 cubed. So I'm going to rewrite 8 as 2 cubed. And everything else stays the same. And now we're going to use the power rule of exponents to say that this means, well, 2 to the x squared on the left. And on the right, here's the key change. I'm going to turn this into 2 to the power of 3 times negative 6x. Okay, because exponents multiply together when they're raised to exponents. So that is going to be equal to, well, on the left we still have 2 to the x squared, and on the right we have 2 to the negative 3 times 6, so negative 18x. And now I can cancel out the bases because they're common, and you just get x squared equals negative 18x. Okay, and let's bring this over here. What that means is if you bring everything to one side, you have x squared plus 18x equals 0. I'm going to pull out a greatest common factor of x. And now I have two parentheses, okay? I have x equals 0 as one of my solutions, and x equals negative 18 as another of my solution. Okay, so that one's done. Another example. Again, the bases look like they're not equal, but if you look at it for a moment, you can see there are 2's floating all over the place in here because 32 is just 2 to the 5th power. 4 is just 2 squared. So let's rewrite this using some of those. I'm going to say 2 to the x squared times, well, in parentheses, I've got 2 to the 5th, but that's raised to the x. And then over here, I've got 2 squared raised to the 7th power. So work through all those exponents. Let's see what happens. We have 2 to the x squared times 2 to the 5x equals 2 to the 14th. And now continue combining exponents. We have 2 to the x squared plus 5x equals 2 to the 14th. So a couple of notes here. At this point, I used the power rule of exponentials. And at this point, I used the product rule of exponentials. And those are the difference between multiplying exponents together in the case of the power rule and adding them together in the case of the product rule. And now at this point, I can just cross out those bases because of exponential equality and reduce this to x squared plus 5x equals 14, which we move all over to one side because I'm going to be factoring this. We get x squared plus 5x minus 14 equals 0, which turns into x and x with something in the parentheses. Now, if you just think for a moment, it has to multiply to negative 14 but add to 5, so I think 7 and 2 are a good option. And the 7 has to be positive because I have a plus 5x, right? So the 7 has to be bigger than the 2. And now your solutions are x equals 2 and negative 7 to this equation.